Okay, so this year is 2019. It's a very important year for lots of reasons. We'll see in a few moments. But this talk is really about X, Unix, Linux, and why is Unix and Linux so important? What did it really do? First of all, I have to remind you that Unix is a trademark of the Open Group in several countries. It is used as a standard a source code standard for systems that if you program them in source code, you should have your program work. And of course, Linux is a trademark of Linus Torvalds in several countries around the world. Now, from time to time in this talk, you'll see a little asterisk beside a word. That usually means that this is a much longer discussion that would typically happen over beers. And the more asterisks there are, the more beers it takes. Now, first of all, I am really old. This year, I will actually be 69 years old. I started programming in 1969. I first programmed on mainframe computers and then mini computers. I've been programming on Unix since 1980, and I first became introduced to Linux in 1994. The first time I came to Latin America was in 1996, to Caracas, Venezuela. That was pre-Chavez. I've worked for lots of companies, large and small. I've had lots of jobs from programming to systems administration. I taught computer programming and computer science in a small two-year technical college. But most of all, I am a business person, and I am pragmatic, which means that to me, free software is not a religion. It is simply a good way of developing software. I'll also warn you that I'm going to be jamming 50 years of history into a 45-minute talk. And my memory isn't what it used to be. And so maybe I'll remember something wrong, and you say, no, it wasn't that way. You can use that for your talk, okay? Or you can talk to me about it over beers. So let's talk about some of the anniversaries that are going on this year. I am the chairman of the board for the Linux Professional Institute. We do certification of open source professionals so that they can get jobs, good jobs. We separate the certification from training, so you can gain your knowledge any way you want to, and then you take a test to get a certificate which says that you know what you know. That, with recommendations and things like that, can help you get a good job. 25 years ago was the version 1.0 of the Linux kernel. Now, if you bring out operating systems, you know that version 1.0 means that that's the time that it's really useful to people. Before that, you're under development, and it's not quite there yet. But when version 1.0 comes out, it's a signal to everybody that you should be using this to do real work. And in 1994, version 1.0 of the Linux kernel came out. It was also 25 years ago that Beowulf supercomputers were created. We'll see a little bit more about them later on. But this was a major application for GNU Linux at that time. And most of the major distributions came out either in 1993 or in 1994. Some of those distributions are no longer with us. Distributions like Soft Landing Systems and Yggdrasil. But some of those distributions are still with us, and Debian, of course, is one of those. Debian was formed in 1993 and had its first major release in 1994. It's also been 30 years of the World Wide Web. Tim Berners-Lee developed that at CERN, and it's been 30 years that the World Wide Web has been here and helping people use the internet. It's also been 30 years of the Unix license plate, and there's lots of beer stories about that and what that means. But going back even further to 1969, as you know, it was people walking on the moon. And the entire world came to a halt in these days, 50 years ago, when we allowed ourselves to imagine that we could leave the planet and walk on the moon. Woodstock, a big music festival in the United States with a lot of the bands that maybe your fathers or grandfathers know Jefferson Airplane and the Eagles and the Grateful Dead came to Woodstock to play, Jimi Hendrix and others. In New York City at the Stonewall Inn was the beginning of the LGBTQ movement in the United States, where people were treated badly by the police and rioted to have their rights. And in New Jersey, at Bell Laboratories, two people, Ken Thompson and Dennis Ritchie, started this little system called Unix. And we'll see more about that later. The internet was started with a project from the government of the United States called ARPANET. We had a 15-bit address space at that point because nobody ever thought that billions of computers would be hooked together by this thing called the ARPANET. And Linus Torvalds was born. Yes, Linus will be 50 years old this year in December, which makes me feel incredibly old. I wrote my first program in 1969 on an IBM 1130 computer in Fortran with cards. And I programmed a whole series of different computers since then. And finally, 50 years ago was the last time I ever shaved. Now, in the beginning, computers were physically huge and logically very small. Memories were measured in kilobytes, not megabytes or gigabytes or terabytes, but kilobytes. I programmed on a computer that had 4,000 12-bit words. And it had switches and lights on it because that's how you debugged your programs. If there was an operating system, it was an extremely simple one. And then over time, more complex operating systems were created to help people use these incredibly expensive, and by today's standards, incredibly small and incredibly slow machines. Now, there was a lot of people who thought that different vendors brought out different operating systems to lock their customers into their system, to make their customers buy only their system. I was in those companies. I never remembered that discussion. What I remembered was engineers trying to figure out how to make their systems more efficient, how to help their customers solve their problems better. Because if you wanted to lock your customers into your system, you only needed one operating system on your piece of hardware. And as an example, the PDP-11 hardware system from Digital had 11 different operating systems on them. Some were for batch, and some were for time sharing, some were for real time, and yes, they even had a fledgling Unix system on there. So why would you take the bother of supporting all these different operating systems to lock your customers in when you could have done it with only one? So this is an urban legend. Maybe the marketing people had those discussions, but the engineers never did. Now, at this time of 1969, most software was distributed in source code form. You did not distribute a binary distribution because it took a lot of effort to make that. And almost every computer that was out there was a different architecture and maybe a different operating system. So it really didn't make sense to go through the process of developing that. In addition, there was no really such thing as a professional programmer. If you were writing code, it was because you were a physicist or a chemist or an educator or maybe some type of business person who needed the software for their own use. You didn't write software for other people. Maybe you worked for a computer company and you wrote one of these fledgling operating systems, but that was slightly different. There was also no software copyrights or patents in that time frame. If you wanted to protect your property, your intellectual property, you did that through a contract. And so if you wanted to buy a compiler from some company that made one, and by the way, that compiler might cost 100,000 US dollars in 1969. you would first call up the company and you would negotiate with them a contract. Your lawyers would talk to their lawyers to figure out what your rights were in the use of that software. And eventually you'd sign the contract, you would pay the money, and an engineer from their company would show up with the magnetic tape to put that on your computer and get that piece of software working on your computer. That might take a week. And you might run it through a series of tests to make sure the software was working properly. And then you would keep the source code in a safe in case that company went out of business, because you had purchased the software. And the contract would tell you what you could do with that. And often this would take months of negotiating time. There was also many points of sharing of code. After you wrote your program, if you were a physicist or a chemist, you say, what am I going to do with this? Am I going to sell it? Selling software is hard work because people expect bug fixes and documentation, and there wasn't a way, there was no internet back in those days, so you had to advertise your software some way, and that was expensive. And so these people joined user groups like DECUS, the Digital Equipment Corporation User Society, or SHARE, that was IBM's User Society, or Brainstorm, that was Novell's User Society, or they contributed their software to a bulletin board. And from there, people could copy this software for free and use it themselves. And maybe they would contribute bug fixes to it or ideas to it to make it better. And this was the way it was done in 1969 to around 1977. Now, in 1969, in New Jersey, there were these two guys, Ken Thompson and Dennis Ritchie, who wanted to work on operating systems. Ken Thompson had been working on a large project, but was removed from that project and brought back to Bell Labs, a research organization. And they found a cast-off PDP-7 computer in the hallway. Nobody was using it. It was turned off. And they said, could we use this to work on our little operating system? Now, the PDP-7 was so small and so miserable as a computer system that it didn't even have an assembler for it. So they had to do a cross-assembly from writing the Unix kernel from one machine, punch it onto paper tape, and load it onto the PDP-7, and then debug it with switches and lights on the front panel. And they did this, and they said, well, we're going to write this small kernel, and we're going to put just a small amount of functionality in there. One reason was because the PDP-11 was so small. They couldn't build a gigantic kernel. It wasn't big enough to hold one. So they created a small kernel, and a lot of things were out in user space. This was different than a lot of operating systems of the day when larger, more expensive machines, because they would put all that functionality into the kernel of the operating system itself, which made it unstable. And so Ken and Dennis thought, no, we're going to make a small kernel, and we're going to have a lot of the other functionality in libraries and things like that out in user space. Now, the first couple of renditions of Unix were written in assembly language for the PDP-7. But eventually, the PDP-7 was too small and too slow, so Ken and Dennis got a PDP-11, which was a little bit larger, 64,000 bytes of address space, as separated out into instructions and data, system, and user space. So actually, the total amount of memory was 4 times 64K. And once again, they had to rewrite the kernel completely differently, again, because the PDP-11 was a different architecture with a different instruction set, and of course, a different assembly language. And so they rewrote the kernel again in machine or assembly language, And Dennis said, this is too hard. I'm going to write a language that we can program in something higher level than assembly language. And so he wrote the language C. And so they rewrote the kernel again in C. And they said, oh, thank goodness we're finished. We never have to do this again. And then somebody said, well, we'd like to have it on the Interdata 832. Oh, we just have to recompile it. No, it has a different architecture, different devices. You can't just recompile it. And said, oh, well, maybe we can separate the kernel into two parts. The parts that's standard, like scheduling processes and upper level management of memory, from the parts that are dependent on the hardware, like the device drivers and the bus structure. And if we do that, then we have to rewrite less of the kernel every time. And as they took the kernel from computer to computer, the kernel and the operating system became more and more portable as they went along. Now, in the beginning, the telephone company, AT&T, Bell Labs, didn't pay any attention to what Ken was doing. And Ken loved to go out to universities and talk about operating systems, and he would take along a tape of his favorite operating system, Unix, and work with the students at the university so they could see how the operating system worked and they could perhaps make changes to it. And there was no charge for this because he just gave them the code. But eventually, Bell Laboratories kind of woke up to this and said, no, this is our intellectual property. We're not going to let you do this anymore. We're going to license it to the universities for a very small amount of money. Now, if you're a research university, like University of California, Berkeley, or Columbia, or MIT, or Carnegie Mellon, you got the code for $350 to use over every computer in your campus. But if you were not a research university, you were a government agency, or the military, or a commercial company, or a small 2-year technical college, the price was $160,000 US per CPU for Unix. I know because I tried to buy it for my little 2-year technical college. And you had to tell them what your serial number was. Now, I want to see a raise of hands. How many of you know the serial number of your laptop computer? That's what I thought. You're slackers. You know, but you had to know that if you wanted to get Unix for it. And if your laptop computer broke, you wanted to transfer it to another laptop computer, you had to call them up, find the person inside of AT&T, tell them what the new serial number was, and then you could transfer it. That was almost impossible. But because this Unix thing was becoming more and more portable, there was a trade-off at this point in time that computers are becoming fast enough and cheap enough, and the memories were big enough that the movement moved from trying to save the computer and get the extra cycles out of it to recognizing that retraining human beings in different operating systems was more expensive than simply buying another computer. And so the focus was shifted from making the operating system, squeezing every cycle out of the computer, to making it so that you could do the same instructions, the same commands, as you went across different computer systems. And this was very important. Now, other types of contributions of Unix were things like taking the command interpreter and moving it out of the kernel and making it a user-level process. So the shell, as we call it, and it used to be shell, and then C shell, and then K shell, and then Bourne shell, and now the Bourne again shell, bash. The shell was a separate process. And the shell allowed you to use these things called pipes and filters, which was a very unique concept. The ability not to have to create a bunch of temporary files to hold your information, but still to take the output of one command and feed it directly into the input of the next command. And this was such a radical concept that a man named Doug McElroy, who came up with it, had to work to teach Ken Thompson and Dennis Ritchie what he was talking about. But now, most people, when they use a command, they think pipes and filters. Oh man, that is the greatest thing in the world. But it was Doug McElroy who came up with that concept. Other things over the years that Unix and Linux came out with, network file systems like NFS. I still remember the year of the network file systems where people talked about RFS and GFS and everything else, and NFS seemed to, with all of its warts, seemed to become the thing that captured people's imagination. The X Windows system, as a client-server relationship over the internet, over networking, also came out. And there were many more interesting concepts of computer science that were first introduced to Unix systems. Now, by 1982, the proprietary system era was still in full force. Digital Equipment Corporation had VMS. Hewlett-Packard had their proprietary operating systems. IBM had MVS and others. But there's this little company in California at Stanford that had this little single-board computer that was very powerful and very cheap. And this company became known as Sun Microsystems, and they wanted an operating system to go on that. And first they went to DEC, they said, could we buy VMS from you? And DEC kind of laughed at them. And they looked at CP/M, another operating system, but that was weak and miserable, and so was MS-DOS. Come to think about it, MS-DOS is still weak and miserable. But they went to the University of California, Berkeley, and they saw this thing called Berkeley Unix. And there was this guy named Bill Joy who had been on the Berkeley Unix team, and he came to Sun Microsystems, and he helped them port Berkeley Unix to their little single-board computer. But it was still $160,000 for a license for Unix. And so they went to AT&T and said, if we only put this in binary form, if we don't distribute the source code, could we distribute it for a lot less money? And AT&T said, yes. We charge you only $350 if it's in binary form. And so Sun started selling these workstations with Unix on them for $350 for the Unix license. Now back in those days, the workstation was still $5,000 or $6,000 or $10,000. So $350 for the software license was not a lot of money. And for that, you got a 2-user license. That's strange. Why 2 users? Well, you have the general user who's logged in doing their work, but the second user might be the root user. Or it might be UUCP logging in to transfer data. Or any number of other things that might log in the background to do this, and that's why you needed 2 users. But you also had an unlimited user license that you could purchase for a little bit more money, and people could log in over the Ethernet. Now, other companies started to see this and say, hey, this is a great idea. Digital had been supporting Unix, but only from a hardware standpoint. They would fix the hardware if it was broken. They did not distribute Unix themselves. They did not sell services for Unix. But they saw Sun Microsystems doing this, and they said, yeah, we'll bring out our own version of Unix in binary form to take advantage of this licensing deal. And so that's why a lot of these Unix vendors started putting out Unix in binary-only form. Not necessarily because they were trying to protect their intellectual property, but it was because they got a cheaper license from AT&T. At that time, there were 2 different types of Unix systems. There was one that you could get from Bell Laboratories, the telephone company, called System 5. Originally it was System 3, then System 4, then System 5. But System 5 only had a swapping type of virtual memory subsystem. So the largest program you could possibly hold was limited to the amount of RAM that you had, main memory. They gave you two compilers, one C and one Fortran 77. But their networking was limited to something called UUCP, Unix to Unix copy, that basically would use a serial modem to call up another system, transfer your whole file, transfer your mail, and then shut it down, and that system would then send it to another system. This is called store and forward. Berkeley Unix, however, also known as BSD, Berkeley Software Distribution, had demand page virtual memory. So your program was not limited to only the size of your physical memory anymore, but was limited to the address size of your CPU. And so as a 32-bit CPU, it could be 4 billion bytes in size. They also included 3 compilers, C, Fortran 77, and Pascal. Pascal was used a lot by educational organizations, and it was a nice little compiler. But most importantly, it had TCP/IP. And with that, you could have not store and forward, but you could have packet switching to be able to transfer data huge size. It had Ethernet support. A lot of things that System 5 did not have. And so most of the vendors went with Berkeley Unix instead of System 5. Now, at Digital Equipment Corporation, we had a big discussion about what we should do, System 5 or Berkeley. We almost went with System 5 for one reason. We realized that the University of California, Berkeley, did not have an advertising budget. But AT&T would continue to try and push System 5 for 4 or 5 years with advertising every week, every place. But still, Berkeley was the better system. Now, there was one person at MIT who didn't like the concept of a binary-only Unix system. Having been at MIT, they were used to getting the source code for these Unix systems because they were a research university and they had a source code license for Unix that was across the campus. And he started getting these binary systems from these different vendors, and he would ask for the source code. They said, no, yes, you have the source code license from AT&T, but you need to get our source code license also, and that'll cost you an additional $35,000. Now, to put this in perspective, in 1973, my parents bought a 3-bedroom house on a 1/4 acre of land, all brick, with a kitchen, a family room, and just a nice house for $32,000. So the source code license for Unix in those days was more than my parents paid for their house. And he said, oh, no, I'm not going to stand this. I'm going to create this operating system that's going to be a complete operating system available in source code, and I'm going to call it GNU. GNU, okay? And of course, that person was Richard Stallman. And in 1985, he started the Free Software Foundation to act as a funding and logistical place for developing this software system. Now, the interesting part of this is he didn't start immediately writing a kernel. Because if he had, writing a kernel back in 1984, the kernel would have been obsolete by the time anything ran on top of it. So instead, he started writing applications that people could use on top of any operating system. And the first application he wrote was Emacs. And some people say he could have stopped with Emacs because it was a complete operating system itself. But he continued on, and there were compiler suites that were generated and utilities generated. And the thing was, you could use this on VMS, you could use this on MVS, you could use this on all these other systems, on top of Unix systems. And people said, oh, the same commands and the same software and the same programming interfaces across all these different systems. And that allowed the people to be more portable across all these systems. And my microphone is falling off. There we go. Now, this code also allowed little companies to start up. They pre-packaged the code, and they would distribute it on CD-ROMs and things like that. And companies like Primetime Software and bookstores that sold Unix GNU software on these CDs and books. Before this, O'Reilly existed as a company. And they wrote books on how to program Unix systems, how to use Emacs, all these things. But O'Reilly thought that Unix was dying. And so they actually stopped producing new Unix books, and they started producing books on how to program Windows NT, how to program Microsoft stuff. And I don't blame Tim O'Reilly for that, because he had a company that he was trying to keep going. But eventually, other companies like Cygnus came out. I've only got 12 minutes left, so I have to speed up a little bit. But Digital Equipment Corporation was supporting Unix. They started to produce their own systems, and that's why in 1983, I went there to join in their concept. There was also a big battle between Unix Systems Labs, which consisted of Sun and AT&T, battling all the other Unix vendors to capture the Unix market. And eventually, they merged together. But before they did, they started a lawsuit against a little company called BSDI that was taking the BSD software that still needed an AT&T license, and they were distributing it for $100 for the distribution and the source code. And so Unix Systems Labs started suing them, and this suit went on until 1994. Now remember that date. It's very important, because in 1991, a university student in Helsinki, Finland, said, I'm going to write an operating system kernel just for fun. And this kernel became, of course, Linux. And people used all of the BSD code and code from, all the GNU code and code from BSD and code from MIT to put together Linux distributions. Now, why could this happen at this time? What was so important about this? Because at this time, the Intel 386 processor had been out for a number of years. And the 386 processor was the first processor from Intel that actually supported demand page virtual memory. The 286, the 186, the 8088, and all the rest were swapping systems. And Linus had a brand new 386 computer with this miserable, crappy operating system on it from a company we will not mention their name. And he knew that there was a better operating system than that, and it was called Unix. And so he decided to use his computer to write this new kernel. And a lot of other people had these systems that were being retired from their professional system to a hobbyist system, a system at home. And the internet was now moving to the home. It wasn't just in universities or companies. It was coming into the home, made it a lot easier. There was a lot of information online about how to write computers, and the World Wide Web was maturing. So in 1994, 10 years after the GNU project started, people were able to create this little Unix system. In 1994, I saw Linux for the first time. I met Linus, and I said, I'm going to help you move Linux from a 32-bit system to a 64-bit system. And so I got him a $30,000 US alpha system to help do the port. And I started to see the power of the free and open source software community, because people would buy these systems themselves and then go ahead and port to them and work on the project. And the GNU Linux system exploded at that point. And people started using it for shell systems. ISPs started to use it because it was a lot cheaper than SPARC Solaris and did everything that SPARC Solaris did. And in 1994, Beowulf supercomputers came out because the supercomputer market was dying, and yet we needed supercomputers to do various projects. The most important project was actually something called fluid dynamics. Fluid dynamics is everything. It's weather. It's, even this table, even though it looks solid, it's actually doing fluid dynamics. Heat is fluid dynamics. Everything is fluid dynamics. And so we needed high-powered computer systems to do this. And two people, Dr. Thomas Sterling and Donald Becker, in 1994, conceived of the idea of building supercomputers out of commodity systems. And today, the 500 fastest computers in the world all run Linux. There used to be two computers that ran Microsoft, but they gave up. So, we've had many years where we promised the Unix desktop, and that was because at first, it's been hard, because at first it was only DOS and Windows, and people would actually write down on pieces of paper, type this in, hit return key, type this in. But then what happened was browsers came out, and browsers were different. A scroll bar didn't always look the same. A button box didn't always look the same. And so people stopped doing that. And then we came along with something else. We came along with iOS. We came along with Apple's phones. And they were different still. They were different than Microsoft. And people started using them and say, oh, I have to learn what the computer's actually doing, not just how to hit this button or this button box. And then Android foiled Apple's plan. And so I believe that in the future, Apple will have the same combination as they had with Microsoft. 7% of the systems will be Apple, and they'll be very profitable, and people will really like them. But the other 90% will be Android. Because unless you cannot make money with Apple unless you are Apple. If you can say the word Android, you can have Android on your hardware. And that's why. And now we have the cloud. And the cloud is doing the same thing the proprietary systems did before. They hide all of the code from you. They're just as proprietary. Even though they're using Linux underneath, they're just as proprietary as they used to be. And we have to fight against this. We have to protect people's privacy. We have to help them understand the issues. Because if they don't, then they're going to be exposed to the same proprietary stuff that we always have. So as a summary of this history, Unix created portable code, but more importantly, portable people. And GNU Linux relit that, saved them from Windows NT in the server system and on the desktop, and helped to create the free software culture, which has been added to by Creative Commons and other types of free software licenses. And when I told people at Digital that what I was doing, they laughed at me. My managers laughed at me, and now all of those managers work for IBM because they all went to work for Red Hat, and IBM bought Red Hat. So the future. We have a bunch of users out there, and they really don't care about Debian. They really don't care about free software. We have to educate them. We have to go out there and tell them why they should care about this. And we also have some companies who swear that they now love open source. And I will tell you that there's three types of love in the ancient Greek. There's agape, the love of mother for child, the love of, God for children, God for humans. There is philos, brotherly love, the love that we have with our friends and colleagues. And then there's eros, the erotic love, the love that we, the dirty, down deep love. And that's what some of these companies, the love that they have for free software. And before you start dealing with them, you put on your condom. We are close to world domination. More and more companies are now saying, yes, we should be using free software. But we have to keep fighting for what we need. We have to keep fighting for open hardware. We have to keep fighting for our governments, our universities to be using free software. Now, I'm working on a series of different projects, one of which we're going to be talking about here, Knidos Lukos. Another one is I'm the chairman emeritus of WIT, a company. The Knidos Lukos project is very interesting. It's a hardware platform that's being designed and manufactured here in Brazil, and we hope through the rest of Latin America, and it's going to be open so that any other country can use what we're doing to be able to make this hardware in their country. It's not completely open at this point, but we are working in that direction, and we want to have a completely open system that is completely verifiable by any country to see if there are trapdoors or Trojan horses or malware in either the hardware or the software. Now, when we announced that DebConf was going to be here in 2019, I started going around the world trying to promote it. But Curitiba is my second home. I have a godson here, his name is Kawan. I have a brew pub here, it's called Hop and Roll. And we are here to also promote Knidos Lukos, which is Portuguese for crazy canines. There's going to be a BOF today in room 109B at 3 o'clock for the people that are interested in Knidos Lukos and perhaps helping out with that. And I'm looking forward in the next 2 years to retiring fully after 52 years in computers to start my retirement project of maddog's monastery and marina of math, music, microcomputing, microbrewing, micro-winery, micro-distillery, and bait shop. Because if you have a marina, you need a bait shop. And this is going to be opening in 2025 AD. I welcome you all to join. And finally, for the people who say to me, thank you for all the time you spent with free software, going around the world and doing this stuff, I tell you that if you want to see the most important person in free and open source software and hardware, then when you get up in the morning, you look in the mirror. Because that person is you. You are the people who can help to promote and make free software work. Thank you very much. I have 70 seconds left. I should have shown you when I announced Linux, the Linux kernel, one of my other tattoos. And today, here, for the first time, any place. No, it's not on my butt. I will show you my new tattoo of Tux dressed up as a pirate drinking beer. For those of you that want a picture of this, I will not be wearing my warm-up pants for the rest of the day, so you can get a picture anytime you want. Thank you very much for coming.